93 million miles away. Something deep inside the sun has been quietly changing. 40 years of measurements confirm it. The shift is real, it's ongoing, and its consequences reach every living thing on Earth. Yet almost no one is paying attention. The sun keeps its own time, beating out a rhythm that repeats every 11 years. This cycle is the quiet pulse of our solar system, measured in the rise and fall of sunspot numbers and minute changes in the sun's energy output. Most of the time, these shifts are so slight, less than 0.1% in total solar irradiance, that they pass unnoticed on Earth. The sun's light and warmth feel steady, almost eternal, as if nothing ever changes. But beneath this calm, the sun is far from a static ball of gas. Magnetic fields twist and churn, shaping the familiar pattern of solar maximum and minimum. This is the expected order. A system so regular that satellites and power grids plan around its gentle ups and downs. If the sun's rhythm is so stable, what exactly could be quietly changing inside it? And why are scientists paying such close attention now? Listening to the sun is not a poetic phrase, it's a scientific reality. For more than 40 years, researchers have captured the sun's internal sound waves, measuring their pitch and tempo with instruments like the Birmingham Solar Oscillations Network. These acoustic waves, called P-modes, ripple through the sun's core and outer layers, carrying secrets about its hidden structure. In the data, scientists noticed something odd. The frequencies of these waves, measured in just a few tenths of a microhertz, were shifting in a pattern that did not match the usual solar cycle. This was not a one-off blip. The same fingerprint showed up across multiple solar minima, repeating from cycle 21 through cycle 25. Each time the sun reached its quietest state, the internal frequencies landed just a little higher or lower than before, as if the sun's magnetic heartbeat was changing its tune. Multiple observing systems, Bison, Gong, and HMI, picked up the same signal, ruling out instrument error. The shift is tiny, but it is persistent and real, an internal fingerprint rather than a surface event. For the scientists who study the sun's inner workings, this is more than a curiosity. It is undeniable evidence that something deep inside our star is quietly, steadily changing, measurable, and unfolding right now, whether we notice or not. Inside the sun, the search for answers has become a race between rival theories. Some researchers look to the tachocline, a razor-thin layer of shear at about 70% of the sun's radius. This region, just beneath the convection zone, has long been seen as the engine room of the solar dynamo. If the tachocline's shape or flow shifts even slightly, it could change the very way the sun builds and stores its magnetic fields. Others see the story playing out higher up, in the churning convection zone itself. Here, the slow meridional flow acts like a planetary conveyor belt, moving magnetic flux from the equator toward the poles and back again. Over recent cycles, this deep return flow has weakened, while magnetic activity seems to be squeezed into an ever shallower layer just beneath the surface. Some models suggest the sun's dynamo is now operating closer to the skin than ever before. The debate is far from settled. Each hypothesis explains part of the evidence, but none can claim the full picture. For solar physicists, the mystery is not a puzzle to be solved overnight. It is an unfolding investigation, with every new measurement raising as many questions as it answers. A single solar storm can change the rules for everything in orbit. When the sun hurls a blast of energy toward Earth, the upper atmosphere swells, dragging on satellites that normally glide through near vacuum. In May 2024, a G5-class geomagnetic storm, the most powerful in over 20 years, triggered just such a chain reaction. SpaceX lost nearly 40 Starlink satellites in a matter of days, their orbits decaying as atmospheric density spiked far beyond forecast. Operators scrambled to shift the rest into safe mode, but the damage was done. The sun's reach does not end in space. On the ground, the October 2024 storm forced grid managers in Alberta, Canada, to watch as transformer stress levels climbed. Geomagnetically induced currents, invisible but relentless, threatened to overheat critical infrastructure. These are not isolated flukes. Each disturbance ripples through navigation systems, distorts radio signals, and can even nudge the chemistry of the upper atmosphere. Some researchers warn that spikes in ultraviolet output during solar flares might alter ozone or affect climate feedbacks, though the scale of these changes remains uncertain. What is clear is that the sun's subtle changes can have real, measurable consequences, sometimes sudden, sometimes slow, but never entirely predictable. A change inside the sun should be front-page news, yet the story barely registered beyond a handful of science sites. The signal is subtle, a drift in frequencies measured in millionths of a hertz, unfolding over decades, not days. There's no dramatic image to capture, no sudden crisis to demand attention. Reports stayed buried in specialist journals and university press releases, their technical language keeping the mystery at arm's length. Mainstream headlines moved on, crowded by events that feel more immediate. Scientists themselves tread carefully, wary of overpromising before every detail is checked and rechecked. In the end, a discovery that could shape the future of space weather and technology remains hidden in plain sight, filtered by caution and the quiet pace of slow science. The mystery inside the sun refuses to resolve itself. Every new data point adds to a record that is both precious and fragile. The world's longest-running solar observing networks, BISON, GONG, and HMI, depend on steady funding and international cooperation, yet their future is never guaranteed. Without continuous, uninterrupted streams of measurements, the subtle fingerprint of change could be lost in the noise. Scientists are caught in a race against time and budget, needing longer baselines to confirm the trend, and sharper models to connect interior changes to surface storms. The cause behind the sun's shifting heartbeat remains unsettled. Researchers call for stronger links between solar physics and fields like space. Weather forecasting and risk management, knowing that only by combining disciplines can they piece together the full story. For now, the sun's internal evolution is a living question, one that demands vigilance, patience, and a willingness to follow the evidence wherever it leads. Right now, the sun's deep rhythms are shifting, quietly but undeniably. What else might we miss if we do not look up? The cosmos changes, whether humanity pays attention or not.